Deep within a discarded metallic housing, an invisible threshold is crossed. A ceramic magnet, barely larger than a coin, rotates exactly 1 millimeter past a stationary copper coil. In that fractional second, the invisible architecture of a magnetic field violently shears. Electrons are forced from their stable atomic orbits. A pulse of raw, kinetic potential is born. You have been conditioned to believe that generating electricity requires industrial infrastructure, vast capital, and a decade of financial debt. It is a fabricated illusion. You only need rotation, copper, and a moving atmosphere. Right now, if you walk into the polished showroom of a modern solar installation firm or browse heavily curated government energy rebate pages, you will receive one monolithic answer for residential energy independence: photovoltaic silicon panels and lithium batteries. A modest grid-tied rooftop configuration, perhaps 10 standard panels covering roughly 300 square feet, will extract between $15,000 and $25,000 of your capital. That specific price absorbs the inverter, the extruded aluminum racking hardware, the copper wiring, the bureaucratic permits, and the human labor. Then comes the burden of chemical storage. To actually utilize your accumulated solar harvest when the Earth rotates into darkness or during centralized grid outages, a single Tesla Powerwall commands roughly $11,500 as of 2024. A comparable lithium iron phosphate battery array from manufacturers like EG4 or SolarArc demands between $8,000 and $14,000, dictated strictly by its capacity. Before you have flipped a single light switch in your home, you have surrendered between $23,000 and $39,000. And here is the physical reality that rarely appears in their glossy sales brochures. The National Renewable Energy Laboratory in Golden, Colorado, has meticulously documented that standard silicon photovoltaic panels degrade at a median velocity of 0.5% every single year. That metric sounds benign until you apply the ruthless physics of time. After 2 decades of thermal expansion and ultraviolet exposure, your expensive array is producing 10% less than its rated output. The electrochemical reality of the chemical batteries is a significantly steeper decline. The vast majority of lithium battery warranties guarantee only 70% of their original capacity after exactly 10 years. In practice, some drop below that threshold even faster, dictated strictly by the depth of your daily discharge cycles and the ambient thermal conditions in your utility closet. This dictates a harsh structural truth. The single most expensive component in your entire setup is losing nearly a third of its usefulness before your child finishes high school, and you cannot physically fix it. You replace it at full price. Now, calculate the exact temporal intersection of when you actually require emergency power the most. Frigid January evenings, catastrophic ice storms, and the dead weeks of November, when the atmospheric ceiling is an unbroken gray sheet stretching from horizon to horizon. A December day in Columbus, Ohio, provides approximately 3.5 hours of peak solar irradiance. In Anchorage, Alaska, the planetary tilt reduces that to barely 1 hour. Your $20,000 solar apparatus is generating a negligible fraction of its rated capacity at the exact biological moment you require it most. The machine starves when needed. Simultaneously, the mechanical kinetic energy of the wind resource across the vast majority of the United States reaches its absolute peak during late autumn and winter. The Department of Energy's wind resource maps, publicly archived on their Wind Exchange database, demonstrate average annual wind velocities exceeding 10 miles per hour across colossal geographic expanses. This includes the sweeping corridors of the Great Plains, the Midwest, the Appalachian Ridges, the thermal funnels of the Great Lakes, and the coastal boundaries from Maine down to the Texas Gulf. This is raw, kinetic mass moving continuously through the air above your property 24 hours a day, 365 days a year. Nobody can install a meter on it. Nobody can issue a billing statement for a pressure differential. And nobody in the mainstream energy industry wants you to discover how cheaply you can intercept it. Wait until you subject this mechanical build to the unforgiving mathematics of dollar per watt efficiency, because it makes the commercial options look like a very expensive joke. The mechanical reason a discarded ceiling fan motor functions as a generator is rooted in an electromagnetic principle definitively mapped in 1831. It was then that Michael Faraday coiled copper wire around an iron ring and physically demonstrated that a changing magnetic field induces an electric current within a nearby conductor. Every single generator on Earth, from the massive hydro turbines buried in the Hoover Dam to the tiny friction dynamo rubbing against a bicycle wheel, operates strictly on this exact physical law. A standard ceiling fan motor is engineered to run this physical process in one specific direction. You feed it alternating current, the induced magnetic field forcibly spins the central shaft, and the attached airfoils push the ambient air downward. But the underlying physics is perfectly symmetrical. If you mechanically spin the shaft by mounting aerodynamic blades and letting the atmospheric pressure provide the rotational torque, electricity flows back out of the motor's internal stator windings. The motor transfigures into a generator without altering a single wire inside it. The critical detail is identifying the internal architecture of the motor you salvage. There are two dominant classifications buried inside modern ceiling fans. The first is an induction motor utilizing a squirrel cage rotor. These require a constant influx of external electricity to manifest their magnetic field, so they produce absolutely zero usable voltage when spun by hand. Skip these entirely. The second classification is a permanent magnet motor. Inside this housing, instead of electromagnets requiring external excitation, there are fixed magnets, usually heavy ceramic ferrite, or occasionally rare earth neodymium, bonded directly to the rotating assembly. When the kinetic energy of the wind sweeps those permanent magnets past the stationary copper stator windings, you generate an alternating current output requiring zero external input. You need no chemical battery to excite the field, and no carbon brushes to structurally wear down. You have only fixed magnets, coiled copper, and the wind. Here is how you identify them physically at a salvage yard. Pick up the motor block and physically rotate the central shaft with your bare fingers. If you feel a distinct, pulsating series of mechanical bumps or rigid resistance points as it turns, you are feeling magnetic cogging. That is the invisible force of the permanent magnets physically grabbing at the steel teeth of the stator. That motor is mathematically viable. If the shaft rotates with perfect, frictionless fluidity and zero resistance, it is a standard induction motor and it will never generate ambient power without extensive internal modification. Walk away from that one. A standard 4-pole permanent magnet ceiling fan motor, rotating at 350 revolutions per minute, produces approximately 8 to 12 volts of alternating current. To chemically reverse the degradation of a standard 12-volt battery, physical law demands an absolute minimum of 13.8 to 14.4 volts of direct current. At stock atmospheric speeds, the induction falls short. This mathematical deficit is precisely where amateurs surrender. You will not. In 2009, Dan Bartman, a researcher who co-authored the text Homebrew Wind Power, formally documented the mechanical correction. You amplify the voltage through two distinct physical modifications. First, you remove the standard ceramic magnets and bond rare earth neodymium magnets in their place. This directly magnifies the magnetic flux density across the stator coils. Second, you strip the factory coils and rewind the stator using a greater number of turns with a thinner gauge of copper wire. This increases the voltage generated per single revolution, sacrificing only a marginal fraction of total current capacity. Bartman proved that a rewound and remagnetized stator mathematically generates 20 to 28 volts of alternating current at just 400 revolutions per minute. The physics scale rapidly. Route this raw alternating energy through a bridge rectifier, a solid-state configuration of 4 diodes that forces the oscillating wave into a unidirectional stream of direct current. You now possess the exact electrical threshold required to saturate a 12-volt battery bank in a standard 10 to 15 mile-per-hour breeze. If you assume a salvaged housing cannot yield relevant wattage, look to the published data. Researchers at the Federal University of Technology in Akure, Nigeria, published a peer-reviewed structural analysis in the International Journal of Scientific and Engineering Research. They stress-tested a converted ceiling fan motor initially rated for 80 watts of consumption. Subjected to wind speeds between 15 and 20 miles per hour, the instruments recorded a sustained, usable output of 40 to 60 watts. This is documented empirical power, extracted from an object that costs less than a fast food meal. The yield is absolute. 60 watts illuminates an entire circuit of light-emitting diodes through the blackest night. It saturates the lithium cells of your communication devices and computing hardware. It sustains a localized radio indefinitely. Paired with a compact inverter, it absorbs intermittent thermal and entertainment loads. When subjected to a rigorous cost per watt analysis, the modern solar industry shatters. A single 60-watt photovoltaic panel in the current retail market demands $70 to $120, completely excluding the charge controller or the structural aluminum mounts. Your salvaged conversion delivers that exact same 60 watts for a total material investment of $30 to $50. Furthermore, it extracts that power in total darkness and driving rain. The atmosphere never sleeps. Small wind generation possesses a profound, intentionally suppressed lineage. In 1887, Professor James Blythe of Anderson's College in Glasgow constructed a massive, cloth-sailed wind turbine. He harnessed the atmospheric friction to charge heavy lead accumulators, illuminating the primitive electric lamps in his cottage. When he offered the surplus current to the surrounding population of Marykirk, they refused the transmission. They believed the invisible force was demonic. 1 year later, in 1888, Charles Brush erected a 60-foot wind dynamo in Cleveland, Ohio. The massive rotational inertia powered the incandescent filaments of his estate for over 10 continuous years. By the 1930s, the Jacobs Wind Electric Company in Minneapolis had manufactured and deployed thousands of 32-volt turbines across the agrarian plains of the Dakotas, Montana, and Nebraska. These structural giants were practically immortal. Archival records confirm multiple units operating for over 30 continuous years on their factory-installed bearings. Isolated families mechanized their water pumps, washing machines, and evening lighting entirely through the intercepted kinetic energy of the sky. They conquered the isolation. These machines did not vanish because of structural failure. They were dismantled because the Rural Electrification Administration subsidized vast networks of copper transmission lines, flooding those specific farms with centralized coal-fired grid power. The physics of magnetic induction have not degraded a single fraction since Professor Blythe's inaugural rotation. What shifted was the structural monopoly of profit. You can view this financial architecture in the rigid text of modern legislative incentives. The Federal Residential Clean Energy Credit, specifically Section 25D of the Internal Revenue Code, explicitly covers small wind turbines installed by licensed contractors. The gating mechanism is the word certified. Your salvaged motor conversion carries no Underwriters Laboratories listing. It possesses no Small Wind Certification Council rating. It offers no corporate warranty documentation. Therefore, it will never qualify for a federal tax credit. It cannot qualify because there is no corporate entity filing the paperwork and no intermediary contractor collecting a margin of profit. State-level net metering programs enforce interconnection agreements with local utility grids. Those rigid contracts demand localized equipment adhering exclusively to IEEE 1547 standards for grid-tied inverters. Your homemade turbine, silently feeding direct current into a lead-acid battery in your garage, interconnects with absolutely nothing. It operates completely severed from the regulatory framework. That framework was not designed to exclude your machine by accident. It was heavily engineered around manufactured products and professional installation services that generate compounding revenue for utilities and corporations. A human being who spends $80 and permanently ceases the purchase of external kilowatt hours is an entity the modern grid actively fears. Yet, assembling this physics experiment violates zero laws. You are completely invisible to the modern incentive structure because it was engineered to keep you dependent. Observe who is actively exploiting this structural flaw right now. A retired machinist residing in rural Missouri, identified strictly as Terry on the engineering archives of field lines. Constructed a 3-blade kinetic turbine utilizing a scavenged ceiling fan motor. He carved 3 aerodynamic airfoils from 4-inch schedule, 40 polyvinyl chloride pipe, and anchored a tail vane cut from discarded plywood. His absolute total material expenditure was $41. He elevated the generator on a 20-foot section of steel pipe, sunk 3 feet into a concrete footing, and stabilized the vertical axis with 3 tensioned guy wires. Subjected to sustained atmospheric currents of 12 to 15 miles per hour, his instrumentation verified 14.2 volts of direct current traversing the bridge rectifier, steadily saturating a pair of deep-cycle marine batteries. Those chemical cells power the light-emitting diode fixtures in his workshop and a localized radio receiver every single evening. He has subjected this system to continuous mechanical operation since 2019. His absolute only mechanical failure was a single set of degraded steel bearings. The replacement cost was $6. The mathematics are ruthlessly efficient. This apparatus generates approximately 350 watt-hours during a favorable atmospheric day. Across a month featuring 15 functional wind days, the yield is roughly 5.2 kilowatt-hours. Calculated against Missouri's average residential tariff of 13 cents per kilowatt-hour, he is extracting 68 cents of localized utility value every month. It sounds financially microscopic until you apply the timeline. The machine entirely erased its own material debt in exactly 5 months. Every single watt-hour generated since that date has been entirely free. The debt is erased. Across the Pacific, within the electrical engineering department at the Technological University of the Philippines, academics orchestrated a community electrification matrix for isolated coastal fishing villages entirely severed from centralized grid infrastructure. They engineered 20 small-scale wind turbines from discarded ceiling fan housings. The local material cost per generator was exactly 18 United States dollars. In the relentless, steady friction of the coastal trade winds, the university documented an average sustained electrical output of 35 to 50 watts per single turbine. Those scavenged permanent magnets have been saturating cellular batteries, illuminating localized dwellings, and powering communication receivers continuously since 2017. Their 7-year maintenance archives dictate only 2 requirements: standard bearing replacements and occasional blade rebalancing. There were no catastrophic inverter failures. There were no battery management system software crashes. There were no mandatory firmware updates. You have only fixed magnets, rotating past conductive copper, exactly as Michael Faraday mapped it 194 years ago. Physics does not require a software update. Now, subject this reality to a metric that the industry aggressively suppresses. The American Clean Power Association acts as the lobbying shield for corporations selling residential wind turbines priced between $5,000 and $50,000. Their heavily distributed consumer guidelines explicitly advise against homemade structural turbines, broadly citing vague safety and performance liabilities. Yet, across their entire institutional history, they have never published a single, peer-reviewed, side-by-side empirical study comparing the exact electrical output per dollar of a properly tuned, amateur-built turbine against their absolute cheapest certified commercial unit. That specific mathematical comparison is intentionally absent from their literature because the empirical data would utterly dismantle their retail pricing structure. A $40 salvage build, outputting 50 watts, yields 1.25 watts for every single dollar spent. A $5,000 commercial turbine generating 400 watts yields exactly 0.08 watts per dollar. The scavenged motor delivers roughly 15 times more generating capacity per unit of capital. The ratio is lethal. That single mathematical equation is the exact reason this physical technology is restricted to obscure hobbyist archives rather than illuminated retail shelves. Furthermore, this extreme cost advantage violently extends beyond the primary generator. A commercial small wind configuration demands a proprietary digital charge controller. That heavily guarded circuit board extracts $200 to $400 and is cryptographically locked to communicate only with that specific manufacturer's turbine. A ceiling fan conversion natively interfaces with a generic pulse width modulation charge controller. You can acquire one for $8 to $15 from any generic international manufacturer. Commercial installation mandates a certified electrical technician, extracting $500 to $2,000 in human labor for the physical wiring, bureaucratic permitting, and localized inspection. The scavenged apparatus connects directly to your chemical battery bank utilizing standard 10-gauge, outdoor-rated copper wire and basic crimped ring terminals. These are crude mechanical tools you either already possess in a drawer or can purchase for under $20. At every single progression in the commercial pathway, a corporate entity extracts a mandatory markup. At every single progression in the self-built pathway, you utilize raw, unbranded commodity hardware secured directly from the plumbing and electrical aisles of your local hardware store. Here is the exact physical inventory required. The core induction mechanism is a permanent magnet sealing fan motor, extracted from a yard sale or an online classified listing for $5 to $15. The kinetic airfoils are three separate sections of 4-inch Schedule 40 polyvinyl chloride pipe, cut lengthwise at a calculated angle utilizing a standard jigsaw to simulate an aerodynamic curve. The total polymer cost is roughly $8. The central hub is a standard threaded steel floor flange harvested from the plumbing aisle, costing $4, permanently bolted to the motor's rotational shaft via a coupling nut. You must utilize stainless steel hardware across every connection point to mathematically eliminate atmospheric corrosion. The directional tail vane is a rigid plane of thin plywood or sheet metal, roughly 12 by 18 inches, mounted on a 2-foot extension arm behind the motor housing to force the airfoils into the incoming wind vector. That raw material is $2 to $3. The vertical tower is a 20-foot extrusion of 1.5-inch Schedule 40 steel pipe anchored 3 feet into a poured concrete footing. The steel requires $20 to $30. 3 radial sets of steel guy wires, tensioned with mechanical turnbuckles, demand $15. 2 60-pound sacks of dry concrete mix run $10. For the electrical translation, you require a 50-amp solid-state bridge rectifier for $3, a 10-amp pulse width modulation controller for roughly $10, and 50 feet of 10-gauge copper wiring for $25. If you purchase every single atom of this system brand new, your absolute maximum capital ceiling is between $75 and $120. If you scavenge the heavy motor, the steel pipe, and the tail plane, your physical investment collapses to $30 to $50. The required human skill level is primitive. If your hands possess the mechanical strength to operate a powered hand drill, push a steel hacksaw through soft plastic, strip the insulating jacket off a copper wire, and apply rotational torque to a hex bolt with a basic steel wrench, you possess every single biological requirement to command this project. The final wire routing is fundamentally less complex than installing the actual ceiling fan in a standard living room. William Kamkwamba, who constructed his initial wind generator in Malawi at the age of 14, utilizing discarded tractor parts and stripped bicycle frames, later documenting the physics in The Boy Who Harnessed the Wind, empirically proved that formal electrical engineering degrees are not a prerequisite for extracting kinetic energy from the atmosphere. What is an absolute, unforgiving prerequisite is mechanical patience during the blade balancing process. If your 3 individual plastic airfoils do not possess near identical mass and exact pitch angles, the entire structural turbine will violently oscillate on top of the steel tower. This geometric imbalance will rapidly accelerate the degradation of the internal steel bearings and broadcast a low-frequency acoustic wobble that will penetrate neighboring properties. Place each separate blade on a highly calibrated digital kitchen scale. Physically shave the rigid polymer with a heavy steel rasp or aggressive sandpaper until all 3 components match within exactly 3 grams of mass. Mechanically lock the pitch angle so each separate foil bites the air at precisely 10 to 15 degrees relative to the 2-dimensional plane of rotation. This localized balancing process demands exactly 1 hour of human labor. It fundamentally shields the machine from years of catastrophic vibrational wear. Respect the rotational mass. There is one critical, non-negotiable structural warning. Absolutely never mount this kinetic turbine directly to your residential roof structure. The physical mass of the building itself mathematically fractures the incoming wind vector, generating highly turbulent, chaotic air currents above the shingle line. This localized turbulence slashes airfoil efficiency by up to 30% and injects asymmetrical kinetic stress directly into the plastic blades and internal steel bearings. The Department of Energy's own fluid dynamics guidelines explicitly dictate that localized turbines must be isolated on freestanding vertical towers. The absolute lowest tip of the rotating blade must clear any physical obstruction within a 500-foot radius by at least 30 vertical feet. A 20-foot vertical pole situated in an open yard effortlessly clears standard wooden fences and single-story outbuildings. The roof is universally the worst structural location for kinetic harvest, regardless of its perceived geographic convenience. Furthermore, strictly avoid salvaging internal motors that possess excessive mass. A motor extracted from an oversized industrial or commercial fan apparatus might weigh 10 to 15 pounds. That heavy rotational mass demands significantly higher incoming atmospheric torque just to break resting inertia. This ensures the heavy turbine will sit entirely motionless during light, ambient breezes that would have easily triggered a smaller motor into generating usable voltage. The structural sweet spot is a motor pulled from a standard 52-inch residential ceiling fan, possessing a physical mass between 4 and 6 pounds. These specific units initiate the production of usable voltage at wind velocities as low as 7 to 8 miles per hour. Now, absorb the absolute physical limitations of this system because you are owed the unvarnished engineering truth. This exact configuration will not power your entire residential structure. A 40 to 60 watt generator slowly saturates a direct current battery bank perfectly calibrated for evening illumination, small communication electronics, lithium phone charging, and highly modest, intermittent inverter loads. If your survival requires operating a thermal refrigerator, a heavy subterranean well pump, or high-draw power tools directly from atmospheric friction, physics demands a significantly larger mechanical system. That explicitly requires either a custom-built, heavy axial flux alternator mirroring the architectural designs published by Hugh Pigott through Scoreig Wind Electric, or a massive commercial unit possessing a significantly higher continuous output rating. Geography dictates everything. If your specific topographical location averages less than 8 miles per hour of annual sustained wind velocity, a small-scale kinetic turbine will yield virtually zero usable electrical energy. You must consult the publicly available wind resource maps generated by the Department of Energy for your exact county coordinates before you invest a single dollar of capital. Flat, expansive terrain possessing total open exposure is the absolute ideal. Dense, mature tree canopies, compressed geographic valleys, and highly congested suburban housing tracts aggressively artificially reduce the effective wind velocity at your specific rotor height. The required maintenance protocol is minimal, but it is not zero. You must anticipate mechanically extracting and replacing the internal motor bearings every 3 to 5 years. A standard pair of 6,203 double-sealed steel bearings costs exactly $6. The polyvinyl chloride airfoils will eventually suffer molecular embrittlement from continuous ultraviolet radiation exposure, particularly if you reside in extreme sunbelt latitudes. You must plan to physically cut and balance replacement blades every 4 to 6 years, demanding roughly $8 in fresh pipe. The steel guy wires require physical retensioning via their turnbuckles once or twice every solar cycle. Your total, absolute annual maintenance cost is roughly $5 to $10 in raw materials and one single afternoon of human labor. But here is the physical reality that none of those technical limitations can ever erase. You have successfully engineered and deployed a localized power-generating apparatus for under $100. It operates flawlessly in pitch darkness. It operates flawlessly in torrential rain. It hums steadily in the dead of January when your heavily financed solar array is functionally suffocated beneath 4 inches of packed snow. It directly intercepts and harvests a continuous kinetic energy source that no multinational corporation can legally own, no localized utility grid can digitally meter, and no government agency can directly tax. And if those internal steel bearings catastrophically fail after exactly 5 years of continuous rotation, you simply unbolt the housing, press in fresh steel for $6, and the system is back online, generating current before the sun sets. Alternatively, you locate another $13 salvaged motor at the next local yard sale and erect a second, redundant turbine. Now, run that exact mathematical comparison against the homeowner who surrendered $30,000 to a solar installation firm. That individual is now staring at a chemically degraded lithium battery bank that strictly demands an $8,000 replacement at year 10, followed immediately by a highly expensive digital inverter swap at year 12. Hugh Pigott, a seasoned Scottish engineer who has spent over 30 years designing, refining, and lecturing on localized wind turbine architecture from his off-grid compound on the Scoreig Peninsula, has meticulously documented the raw output data from hundreds of amateur-built machines constructed by his students across dozens of distinct nations. His published construction manuals, distributed directly through his own archives, mathematically verify that properly balanced, Small-scale turbines consistently achieve a capacity factor between 15 and 25% in geographic locations, possessing average wind velocities of 10 to 14 miles per hour. A capacity factor of exactly 20% on a turbine structurally rated for 100 watts translates to a continuous, average output of 20 watts. Over a full 365-day cycle, that is exactly 175 kilowatt hours. Calculated at the national average residential electricity tariff of 16.5 cents per kilowatt hour, that equates to roughly $29 of harvested electrical value per year from a machine that cost $80 to build. The physical machine pays for its own existence before its first birthday. Every single kilowatt hour intercepted after that precise date is completely free for as long as you maintain the steel bearings. That is a ruthless return on invested capital that no fiat savings account, no corporate solar lease, and no localized utility rate plan can ever mathematically match. The centralized energy industry actively prays you never understand this specific physical math, because the exact second you comprehend the physics, you permanently realize the entire residential energy marketplace is artificially structured around selling you the most heavily marked up, complex version of a system that can be trivially assembled from the exact scrap metal they throw into landfills. The underlying technology is not remotely new. The electromagnetic physics are not complicated. The required elemental materials are not rare. What is missing in the modern era is not human capability. What is permanently missing is a structural system willing to tell you the raw, unvarnished truth. And for the individuals who inherently doubt the durability of scavenged materials, observe the historical record. Hugh Pigott's amateur-built kinetic turbines have operated continuously on the Scoraig Peninsula in the Scottish Highlands, mathematically proven to be one of the most violently brutal atmospheric environments in all of Europe, suffering regular wind gusts exceeding 70 miles per hour for over 2 solid decades. The absolute only maintenance required has been standard internal bearing swaps and the occasional replacement of polymer blades. If a structurally sound, homemade kinetic turbine can biologically survive 20 continuous years of Scottish Highland gales, it can effortlessly handle anything your localized backyard weather system has to offer. Search the archives of Scoraig Wind Electric and read the unvarnished maintenance logs yourself. Go outside, acquire a single piece of copper wire, and pass a magnet over it until you feel the invisible resistance. You are not a consumer. You are a biological organism standing at the bottom of an ocean of moving air, completely ignoring the invisible force that surrounds you.